Uh-huh. Okay, so over to you now, Rusan. Rusan, you ready for me?
All right, so may have a worksheet. I won't ask the worksheet questions, but the topic is absolute value inequalities. That's what we were just doing.
No.
Oh, kind of about minimum and maximum.
You sure is absolute value give you that a two different something that in a minimum and max?
No, the topic say absolute value inequalities, and a part of the question would say using absolute value inequalities, calculate the minimum and maximum diameter, something like that. So.
All right, give me the absolute value equation.
But there's no equation right there, say no.
They must give you something, man. They must give you something with two lines, something in a two lines. Like, for example, they said they have this with a line and they said 2x. 2x plus 4.
Make I ask a different question.
And
You
then
can look at
something like that. This is an absolute value inequality.
all right, just work something like that then. As a fresh of a class. Because as I said, I really start learning the topic then yet.
All right. So the first thing that you need to do here is to split this into equation or two inequalities. So because what absolute value is all about is the location of a number from 0. So if you have a number line like this, you have a number line like this. I'll keep writing two when we're supposed to write one. So I have a number line like this. The absolute value of -2 would have been 2 because it is 2 places away from 0. And the absolute value of 2 will also be 2 because it is 2 places away from 0.
Okay.
So in essence, that is what absolute value is. So there is a number for x. There's a number for x, right? That makes this absolute value be less than or greater than or equals to 8. And that's what we want to find.
Okay.
So what we do, we write this down by saying 2x plus 4 is greater than or equals to 8, or negative bracket 2x plus 4 is greater than or equals to 8. So this is what I mean by splitting them into two inequalities. You understand that?
Yes, so far.
Then you work each of them. You work each of them, so you say 2x being greater than or equals to 8 minus 4. So x now 2x will be greater than or equals to 4. So here x is going to be greater than or equals to 4 over 2. So x will be greater than or equals to 2. You understand this?
Yes, I do.
Over here now, we're going to remove the bracket. Remember, the law says that when you're removing brackets, the sign, the negative sign is going to change what is in the bracket, the sign that is in the bracket. So you'd have had here negative 2x be minus the 4, because the negative sign changes the sign, greater than or equals to 8. See that?
Yes.
And so negative 2x being greater than or equals to 8 plus 4. And 8 plus 4 is equals to 12, right?
Mm-hmm.
So negative 2x is equals to 12. So x now, remember, because the sign must be changed. So you get negative x being less than or equals to 12 over negative 2. So x would be less than or equals to negative 6.
All right, I got that one.
So the minimum number here would be 2 with a negative 6, and the maximum number would be 2. So this would be the minimum number.
Okay, understood.
This is the maximum. Clear?
Yes, it is.
You can write this as you can write this in notation, you know. 6 is x is less than or equals to 4 to negative 6 and greater than or equals to that. So not really possible. If you do this on number line, you're going to get something looking like this. With 6 here, so. And then 2, something looking like that. So I don't think they will ask you about minimum number and maximum number for this one.
Okay.
Any more questions? Davina? Nothing more?
Hold on. Jesus, it's me. Let me simplify something right now.
Here, we should be touching limits in a few days.
Limits?
Yeah.
At this college algebra?
Yes.
Really? Because limits is calculus, you know. You sure it's good?
I guess what she's saying is that you want to ensure that we understand the concept before probably whatever she's gonna teach next. Then limits probably is, I don't know. It's college algebra we're doing, but it's limits. She said we're gonna do next.
I'm just mixing up.
Mhm.
Who is the teacher?
Second,
Who is the lecturer?
Mrs. Roden.
Road, probably
Paula. Huh?
Dohwa,
Second,
Rhoda, Rhonda.
Paula Roden.
Oh, yeah, she mix your class up with the calculus class.
Oh,
Limits is calculus.
okay.
I'm going to do some only for differentiation and integration. More like tape maths.
Oh,
I'll mix it.
I'll just go back through the outline and see.
It's not on the outline.
Okay. So for everything else, I just guess, oh, sorry, whatever else I have to do, I'll just probably have to just go through some questions to see if I get the concept of what we have done so far.
All right.
Yeah.
I'm looking at what she did. Square bracket. And sorry, parentheses back. That is so good. And I'm trying to get it in tune. Interval notation, we just write the beginning and the ending numbers of the interval and use it. So square means square bracket when we want to include the end value. And oh, okay, I see. I don't want to include the end value. Okay. It's basically another way to write the whole thing. All right.
Yeah.
Any other question?
Is mine?
Not so far. As I said, I'm still learning majority of the stuff. I have a long way to go.
You
Just
did,
reach like,
did factorization, right?
yeah, factorization, and lots of indices so far. So we're just learning to like simplify algebraic terms and stuff like that. Multiplying binomials, factorization.
Or
That's where
we did expansion.
Expansion.
We did piecewise function as well.
What is that?
All right. So that's Rusan or Rusan, right?
Ruthan was saying factorization and stuff like that.
Yeah.
Lots of indices.
So like, for example, this is multiplying binomial. Remember that, Rusan?
Yes.
All right. So you can do this.
I think so.
So to go through it with me now. Tell me what to write then.
All right. I don't know if I'm writing about. Is it where you use like?
Write. Just tell me what to write.
All right. Is it where you use the 3x and multiply it by the 4?
All right. All right.
I am
You
multiply
have
by
an
3.
idea, but you don't know how to put it across. Let me help you.
Right.
It is a 3x going to multiply the 3x.
Yeah.
And then the 3x again going to
Times the
multiply
3.
the 4.
Yeah.
And the 3x, the 4 going to multiply the 3x there. And the 4 again, the negative 4 going to multiply that.
The positive 4.
Right. So this is a pattern. So 3x times 3x will give us 9x squared. And 3x times 4 is going to give us 12x.
Oh, the 3 times the 4, no? Well, x.
And then the negative 4 times the positive 3x gives us negative 12x.
Negative 12x.
And negative 4x times positive 4,
4x
negative
minus
16.
16.
Right.
And so now we simplify.
Mm-hmm.
When we simplify this, we get 9x squared minus 16, because 12x minus 12x gives us 0.
Understood. Okay.
Understand?
Yes, I do.
And this is what is known as the difference of two squares. So that is known as the difference of two squares. And we're going to look at some factorization. Cool?
Yeah, cool. Still here.
So we're going to start off with the difference of two, factorizing difference of two squares. And the first one we're going to look at is 3x squared minus 27. And why I choose this one is because I'm going to bring out the basic factorization and the factorization of difference of two squares. The first step here is to find the common factor, the highest common factor. So the first step, find
Highest
the
common factor.
HCF. What is the HCF there? What's the
3.
highest common factor that can go into 3x squared and 7x and 27?
3.
3. So having established 3, so we say 3 into, and so 3 into 3x squared is going to give us x squared. What is 3 into 27?
9.
9. So we are not complete in our factorization. All right. So now, when we are factorizing, so the second step is to factorize difference of two squares.
Why would that be the second step though?
Huh?
Why would that be the second step? Because you have x squared in the bracket same way?
Right. We have x squared minus 9. 9, you know, is a square number, right? And x squared is also a square term.
Right. So when you have both square terms, that's what you're saying, that's where you find the difference of two squares?
Right. So when you have two square terms separated by a negative sign, it is known as difference of two squares.
Okay. Both square terms separated by a negative.
So you are separate, you have two square terms separated by a minus sign. That's difference of two squares.
Okay.
And in dealing with difference of two squares is the square root of the first term. So the square root of the first term plus or minus the square root of the second term.
Okay.
So the square root of x squared is x. The square root of 9 is 3. So plus or minus 3. Everybody following that?
So far. It's still not finished yet though.
No.
Oh God.
So the final step now, the third step is to simplify this.
Then that still can simplify again?
Yes, ma'am. And so when we simplify this, we carry down our 3, right? We carry back down with 3.
Mm-hmm.
Here is it now. We put it in bracket. When you're proficient, then you can
X plus 2, x minus 3.
So you have x and 3, x and 3, right?
Okay.
And then you put in plus sign in here. And if you put plus sign in here, then you have to put minus sign in there.
Mm.
And this is the answer.
Okay. I think we got something like that. All right, we got something like that in my last class, but it was known as factorization by pairing.
No, that is something different.
Okay,
Never
because
look at.
in the pairing are still plus and minus.
Yeah, man, you still get back something similar to this.
Mm-hmm.
All right. Everybody comfortable with this? And I've never seen a end of term, end of semester exam without don't have factorization on it.
This
All
kind of factorization.
All the types.
Okay.
All right. So everybody comfortable with this?
Yeah.
All right. So now I'm going to do a factorization by grouping or pairing. And this will be 6p minus 9ps px plus 4q minus 6qs. And we're asked to factorize this completely. So what we do here is to factorize this pair, then factorize this pair. What is common to the first pair?
P.
3p.
3p. 3p. So 3 can go into 6, 3 can go into 9. P can go into P, P can go into PX. So it's 3p. And so we'd have had 2 here, right?
Correct.
3p into 6p give us 2. And the 3p into 9px gives us 3x. Everybody sees that?
Yes.
Yes.
Carry down our plus sign. So carry down our plus sign. What is common to the second pair?
2q.
2q. 2q. What is it now? This is going to be 2q into 4q give us 2, right?
Mm-hmm.
2q into 6qs gives us 3s. Is it not s and it's x? 3x.
3s.
What do you know? What do you notice about the two brackets?
They cancel out each other. They're the same terms.
They are the same. Not that they cancel out, they are the same. And this is what you must, anytime you work it and you find this, then you are on the right track.
Okay.
Because these two brackets must be the same. These two brackets must be the same. So what I normally do is that once I did this correctly, I find the factor here and then I write back the brackets. No waste no time. Because if this bracket is correct, then it must be correct over here. And so we write back one of the brackets and the two ends. So this would have been 2 minus 3x bracket 3p plus 2q.
Question. For right here, right? You're always going to have a negative and a positive?
No, it's what you're working with.
All right, come out, me I say plus and plus, like from last week class. I mean, I say, shouldn't it be a negative and a positive?
No, it depends on what. If everything was a plus, then you'll have a plus throughout.
Okay.
Right? But once you have a negative, you have negative in there, you must get back a negative.
Okay.
Right?
Yes.
So
everybody
you couldn't
understands
write
this?
it.
Hmm?
Sir, you couldn't write it 3p plus 2q.
Oh, put it over here. This over
Put
here?
it the other way around.
Yes,
You couldn't
man,
write it that
because
way.
it is commutative. So it doesn't matter which one of the brackets you write first.
Okay.
Clear enough?
Yes, sir.
All right, I want to do one more that takes me to something I want to point out. So let's say I have 2ax minus 2ay minus bx plus by.
That's pairing again, right?
Yes, this is pairing.
Okay.
But you have to watch out for something with this one.
All right.
So we're going to factorize by pairing. What is common to the first pair?
2a.
2a. So 2a will leave us with x minus y.
Correct.
Then I carry down my minus sign. So carry down this minus sign. What is common to the second pair?
B.
B. And B now, this negative sign will always change this sign in the brackets. So anytime you have a minus sign here, so this sign is going to change. Hence you get x minus y. You see that?
Yes, changes the one.
So remember that this negative sign change the sign.
The minus one outside changes the one inside.
The one that you're going to put in the bracket.
Okay. Okay.
All right, so we write back one of the brackets. So I'm writing back 2a minus b, 2a minus b, bracket x minus y. Daniel, you're okay? Davina, all right too?
Yes, sir.
All right. So I'm just going to give you a little headache and leave you until next time. And this one is known as factorized trinomials. Very simple, can be very simple, but can be very tricky. Factorize 3x squared plus 2x minus 8. So we're asked to factorize this. In factorizing this, you need to write down, you need to find what is A, what is B, and what is C. Because trinomials, quadratic trinomials, must be in the form ax squared plus bx plus c. Or the plus c not showing. All right. So what we do here is to write down the coefficients. So 3a would equal to 3, b would equal to 2, and c would equal to negative 8. You get that?
Yes, sir.
So we need to find AC. And AC is equal to A multiplies by C. A multiplied by C gives you negative 24. You get that?
Mm-hmm.
So far, yes.
So far. So look here now. You need to find, so you have to find 2 factors of negative 24 that add to give 2. So when you add those 2 factors, you get 2.
6 and 4.
Which is B, right?
Which is B.
Okay.
And so
In
those
bracket.
2 factors will be
6 and 4.
6 and negative 4.
Mm-hmm.
Because if you add 6 and 4, you're going to get 10. And remember, it's negative 24.
I'm still trying to digest negative and positive.
Okay. And so now, you use those 2 factors to split B, to split V. So this is going to give me 3x squared plus 6x minus 4x minus 8.
Okay.
That's what it's going to give me. Clear enough?
Mm-hmm.
And so I go to pairing. So I would pair this.
It could simplify. It could simplify. It has to be paired.
Yes, it's
Like,
paired because you're factorizing.
okay.
So what is common to the first pair?
3x.
3x. So that is 3x into 3x squared gives you what?
X plus 2.
X plus 2. Carry down your minus sign. What is common to the second pair?
4.
4. Yes.
No, continue.
So this is going to give me x plus 2 to right?
Yeah, correct.
And so this is going to be 3x minus 4 into x plus 2. Get that?
You got it.
And that is factorization. That means we have covered factorization tonight in its entirety.
So those are the forms we come into, right? Trinomials, pairing, and just finding the HCF, right?
Right.
Okay.
Those are it. So we'll meet again. I'll advise you when. So enjoy the rest of your